Okay, hope everybody's staying safe. As a reminder, if you have questions about anything, post them in the comments here or on the discussion board on the course site, or send me a text message, give me a call, send me an email. Any of those will work. I know this is a little bit different than usual, but let's go ahead and get through what we're going to get through today. Again, last time we had talked about kind of software engineering, about design documents, things that would help you with your project. I want to do the same thing today, but this is more on the practical side of how to get help with your project or how to work through your project with a team. And today we're going to talk about what are called the version control systems, or VCS. And essentially what a version control system is a system that's designed to take source code, and not just source code. One of the things people always talk about is working with source code, but you can put a lot of things in a VCS. For example, documentation, other assets. You can control a lot of that in kind of this controlled way. It works best. It's kind of primarily designed for source code, but it can be used for other parts of a project as well, documentation being one of those examples. All right, so why would we want to use a version control system rather than just saving the code on a drive on our machine? And probably the main reason for that is that if you have a large team and you want to have multiple people working on the project at the same time, you can't really have them making changes and then uploading their changes and then accidentally overwriting changes someone else made. So in other words, it's a recipe for disaster to have this large group of people all working on the same code base and just kind of making changes however they need to, because changes are going to get lost. You're going to have part of a change of one person, but the other part missing, and it's going to create a problem. So one of the things that VCS does is it allows this group of people to work together at one time. The other thing that it does is it kind of maintains a history of changes and who made them. So in other words, even if I'm working on a project myself, there's some advantages to using a VCS. And the advantage would be like that I can make changes, I can commit them, I can make more changes, I can commit them. And if I ever realize, something I've done in the last 6 months must have caused a problem with something unrelated that I didn't know about, I can rewind the changes I made or look at the history of them and try to figure out what happened. And also, when we apply those changes or add things to the code base or make changes to the code base, we can associate notes with that. So rather than just having the code be different, you can say the code is different. Here's why I made the code different. Or I added these features on this date. So it kind of gives you this built-in history or change log of what was done to the system or to the code. Or maybe it's not code, maybe it's documentation, but you can give this kind of ongoing rolling history of what's been done to that. And that ability to allow developers to look at the changes and then roll them back if necessary is a really powerful thing. It gives you the ability to have rather than looking at the source code as where it is right now, you can kind of look at it as a historical, through a historical perspective, like how did it get to where it is now and why and when did different parts of it evolve. And that can be a really powerful thing. It can be really important, especially if you have some bug that has shown up that wasn't there previously. Figuring out why or what caused that can be the key to finding out what that bug is or resolving it. All right, now, there are a lot of version control systems available. A few of them that you might encounter. CVS is one, not the drugstore pharmacy, but the CVS is concurrent versions system. But that's an open source server-based system. Subversion is another one that's pretty common, also called SVN. And what Subversion is, again, another open source server-based one. And one that you may have heard of or maybe have gone to project sites that have used this is Git. GitHub is a really popular site that stores Git repositories, which we're going to talk about what repositories are in a second. But essentially, that's another open source one. But that has a little bit different model. Rather than being server-based, it's more distributed. So you don't necessarily need a dedicated server setup to use Git. You could actually just install it on your local machine, use it locally. But you can have a server that kind of you push the changes up to as well. A couple other ones, Mercurial is one that I've seen used, especially for Python projects. And then there are a few of them that I've been exposed to that I've used that are related to Microsoft's kind of Visual Studio products. One of them is called Microsoft Visual Source Safe or Microsoft Source Safe. That's a proprietary server-based one like CVS, but Microsoft developed that one. And then there's another one that's Visual Studio Team Services, which is a lot like GIT, but a Microsoft built version of that you can integrate, or that they have integrated with their Visual Studio products. There are a lot of other ones as well that you might encounter, but the ones that I see used most often, or at least the ones that are open source and free, are SVN and GIT. SVN used to be the standard. GIT is now kind of replacing that slowly. And the advantage of GIT, again, is it's distributed. And that distributed nature of it means that you don't have to go through the complexity of setting up a server. But SVN is still used a lot. So we're going to take a look at that today. Now, so looking at SVN, again, I'm just picking one out of this one, and I picked SVN because it's the most common one, and I'm going to lead you through kind of the steps necessary to set something like that up for your project. All right, so looking at SVN, SVN is an open source, centralized, server-based version control system. And what that means is that, what does it mean that it's server-based? That means in order to use this, you have to have a kind of a dedicated server set up with an SVN kind of database on it. And in this picture down here, you'll notice we have this SVN server somewhere on the internet. It doesn't matter where. It could be on some site that hosts SVN repositories, or it could be somewhere else. But the idea here is you can have any number of clients that kind of log in as users, and then they can get access to the code base that's in there. When they make changes, notice down here, there's like this committing changes, or doing a checkout to get the code. Commit pushes data back up to the server, but the server is kind of like the definitive version of everything. And not only does it just have the code on it, but it keeps track of all of the changes and the differences from the previous versions. And as we'll see in a second, you can also make tags in there that say this particular snapshot of where things are on the server. I want to remember that and use that again later potentially. And so that SVN server is kind of the place where all of the source code gets stored, and all of the changes to that source code are also archived, so you can roll changes back if necessary. So it'll handle all of that stuff in the server for us. We don't really have to worry about making zip files and backups and copies of things, but it is stored in a database inside of this SVN server. All right, now a little bit of SVN terminology that also applies to other version systems besides SVN. So you'll see this if you use GIT or another versioning system. You'll also see this similar terminology or the same terminology being used. So the first one there, a repo or a repository. And what the repo is that's basically the database that's storing all of the files, source code or documentation or otherwise, and also behind the scenes, all of the changes that have happened to those files, source code and documentation and anything else on that server. So it keeps track of the current state of the project. So in other words, here's the current state of the project, but it also has kind of backing each of the files in that project, all of the previous versions of that and the changes that have been made from one version to the next version. All right, so that's what a repository is. It's kind of like the central database that's storing all of the data about a project, or you could have even more than one project underneath there. Now, that brings us to this concept of a trunk, and the trunk is kind of like a file directory or folder that's inside of the repo that has all of the kind of main development files stored in there. Now, you'll notice I said a repo could have more than one project in it. So you could make a different trunk inside of a repo for each of the different projects that are stored inside it. So you might, for example, have a trunk for project 1, another trunk for project 2, another trunk for that. And then inside of those trunks, you might have different subdirectories that have documentation. You might have utility code. You might have the actual source code. You might have kind of test harness code. So you can divide things up inside of that trunk. But think of the trunk as like with a tree. That's kind of the main part of some particular project inside of some repository, which might have more than one project. The next thing is a branch. A branch is a point where development of a project has been what we would call forked or divided up into two paths of development. So let's say you're developing let's say it's a game, and you're developing this game, and you decide at some point you want a desktop version, and you want also a mobile version of that. So what you might do is get the game to a point where everything is working on the base system, and then you might fork that by saying, okay, this path here is going to be the mobile version. And the mobile version, we're not just talking about compiling it differently. The mobile version might have different controls. It might have to be rendered differently. But we want to still use the same code base we started with, but we don't want to mess up our desktop version to do that. So what a fork is, a branch is basically where we separate off in this two separate paths of development. One is the mobile changes. One is the traditional desktop changes. You might also have a branch where you create different versions for different clients or different customers, or maybe you just want to do a little bit of experimentation on a project without affecting the main kind of development path. So to do that, you can make a branch, and then you can experiment with, like, again, think of it like a tree. You can experiment over here on this side, and you can leave the other side, kind of the development one that is not affected by those experimentation code changes that you're making. And so branches can be useful. You can actually branch multiple times. You can take something that's already been branched, branch it again. And that's basically just think of that as forking into two different versions. And then each of those versions now will have their own changes that they maintain and their own kind of code base that is based on the original one that it started with. All right, the next term is a tag. And what a tag is kind of like you associate a name for a specific point in development. So you say, all right, I got this code to version 1.0. I'm going to put a tag there. And then in the future, as I work toward version 2.0, I could always go back to that tag that we had previously and switch back to it and look at, okay, this is what it was like at that snapshot of that point in time. So tags can be really useful. You get something to a release candidate, make a tag. And then you can still make changes to the code, but you can always roll back and look at, this is what it was like when we had release candidate 1 or whatever it is. This is what it looked like when it was version 1. So tags give you kind of this way to manually create a snapshot of a point in time. And that can be really useful to go back to that. The next thing, terminology-wise, which is going to be used quite a bit, is the concept of checkout. What checking out is if we go back to this picture, notice checkout is on this is labeled on here. So what checkout is saying get all of the data from the server for this repo, or it could be some trunk inside of there, and check all of that. In other words, make a copy of it, a local copy of it here on my machine, so I can work on it. And notice that checkout, when we have checked that out into the local file system, that becomes what's called a working copy. So you've made a copy of it. It's still associated with the SBN database, but the working copy is one that if we make changes on the local machine, it doesn't make those changes immediately and automatically on the server. It's our working copy. So that means that we've kind of made a copy of what it was on the server, but now we're free to edit it and make changes to it and not affect the server at that point. And we use checkout to do that. Now what update does is that pulls changes from the server into the local copy. So if somebody else has made changes to their part of the code and your working copy has not been updated, we can update it. We can say, hey, make this the most current version. Or you can do that on a file-by-file basis as well. So you could pick one specific file and say, update just this file for right now. And SVN can have the ability, you can update the entire trunk, or you could update just subdirectories inside of there or individual files. It's up to you how you want to update those files in your local copy. Now, commit is going the other way. What a commit is is that's where you're committing changes that you made. In other words, take the changes that we have in our local working copy and push those back up to the server, commit those to the kind of official copy that's stored on the server. And generally the workflow is this. You have multiple users. They'll all kind of connect to some repo and check out some trunk of a project. And then from there, they'll all work on their respective source code, their respective parts of changes to that code. And then they'll commit those when they're done with that. Now, when you do a commit, there's a chance or a potential where two people worked on the same part of the code and they both made changes, and SVN can't figure out which one is the official one or which one's correct. And in that case, we get a conflict. And when there's a conflict, those have to be resolved manually by one of the developers that is as you commit it. In other words, if you try to commit and it detects a conflict, it'll say there's a conflict, and you can actually see what is in one version versus the other version, and then you can accept the changes that are correct in that. But if you're working on different parts of the code, even if it's in the same file, even if it's different parts of the same file, SVN can generally combine those together and understand the changes you made and come up with something that reflects both of those changes. The only case where you get conflicts is if you have something that it cannot resolve automatically. All right, so to set up and use SVN, we need two things. The first thing is we need some sort of repo on a server somewhere. Now, that server is going to hold the database that has your files for that repository. So that's the first thing you need. And you can set up your own server, or what most people do, you can host it somewhere. And as we're going to see here in a little bit, there's a way that, especially for a class project like this, you can host your repo for free. The same thing is true if you were using, instead of SVN, GIT. GitHub is a popular site you can use to put your projects on. Very easy to use. But whether you should probably learn both SVN and GIT and be exposed to them. For right now, I'm just going to cover SVN. So that's what we're talking about right now. All right, so we need an SVN server. The second thing we need is SBN client software. And what SBN client software does is that allows us to, on our local machine, run software that can check things out, can commit changes, can update things. And that essentially to do that, we just need to install some software, connect it to the SVN server of interest, and then we're ready to go and use that. The cool thing about like SVN, for example, on the PC is when we install an SVN client, it can show up in your, essentially the files will just show up in your file system. And with a program called Tortoise SVN, it'll show up with little green check marks or exclamation marks, yellow exclamation marks, or red X's to show things that are different about your local copy than what's currently on the server. And the advantage of that is it lets you kind of manage and visually see things. In other words, it integrates well with the Windows file system kind of file explorer in order to do that. And if you right click on any file that's part of that repo or that branch, you can do things to update just that specific file or that folder. You can commit just certain files and certain things, but it gives you kind of some visual representation through the changing of the icons in your file explorer to what things have been updated and what things haven't. All right, so let's go ahead and try that really quick. So if we go, there's this reusvn.com. That's a site that offers free SVN hosting. In other words, since part of the difficulty of setting up an SVN is setting up the server, it's a centralized system, what they do is they offer a site, a service, where you can host your SVN for free on their site. So all you have to do is register and then create a repo for your project. That will give you a link to your project on their site that you basically then set up the client software, put in that link, and then you're ready to go. So the client, setting up the client software, I'd recommend using Tortoise SVN for that. And notice it's that once you have that installed, you create a folder on your file system, and then you can right click and then say You can essentially connect that to the repo that we created for free on this site by putting in the URL for that, and it will connect that folder now to that SVN, and then you can check that entire thing out for your project. Any changes you make, you can right-click and commit, and so all of the SVN interaction will happen through Windows File Explorer directly. And that makes it really easy. So essentially for your project, what you'll do, set up one repo for your team, have everybody that's going to use it set up the client software, and then all you have to do from there is start checking out the repo, making changes, committing the changes, adding commit notes to it, and everybody can kind of share this one kind of database of your project together. And if somebody makes a change and it conflicts with another one, when you commit, it'll tell you that. And when you check out or update to the most recent thing, any changes anyone else made will now come into your local working copy. So it's actually a really slick system for doing that. One thing that I did say is you might want to learn to use Git also. Git also has client software that you can download and use on the PC. It's becoming very, very popular. The advantage of Git is that it's distributed, meaning that you don't need a server somewhere. You could use it on your local machine, but Git, if you want to use it with a server somewhere, you could use a service like GitHub to do that. So I have some links down here that will help you learn to use things like Git. And just as a quick thing before we're done for right now is let me go ahead and bring up that free SVN hosting. And I think I have to switch what window I'm connected to here. Hold on one second. Okay, for some reason, it doesn't appear to like that. All right, so anyway, here, let me switch back to the presentation since that didn't work. Okay, so I'll have to figure out why I can't get the Chrome window to show up there. But if you go to Ryu SVN and look at that, it's actually really easy to use. So just as a description of, let me go back in my presentation here. So if you go to this website, svn.com, that'll take you to this web page. And what that web page will bring up, it says basically ryusvn.com. It's free and always will be. And notice that if you click on, it's kind of ad-free, has daily backups. You can make private repositories. The idea here is that the limitation here is you only get 50 megabytes per repository, and you can get 4 repositories per account. So in other words, you can only do 4 projects per account, and 50 meg for each of those. Now for source code, 50 meg is a lot of space, but if you start putting assets in there like Photoshop files or cutscenes for videos, you're going to roll over that limit really quickly. It could even just be one video. We'll roll over that instantly. But for source code, it's 50 meg of source code is a lot of source code. So you can put and you get 4 of those. So you can put a fairly large amount of code onto this free service. If you do need more space, they have this thing called credits, where if you donate $1, then you earn just a single dollar earns you another 20 megabytes. So you figure, put $200 donation, then your repo can be grown by 200 megabytes. Or 1 credit is 20, so 10 credits, $10 gives you 200. So for a relatively small amount of money, you can actually have a fairly large amount of storage associated with this by donating money to them and getting credits. Essentially, to use this, I'll walk you through it verbally here. You're going to go to login. Or sign up. You'll sign up. That'll basically put in your email address. You'll put in a password that you want to use. You'll have to confirm the email address, and then you can pick a username. And then after you have that username set up, you will essentially create your repository, give it a name, and then the thing that you're going to want to do after you create that repository is you'll log into the site under login. Once you're logged in, there'll be a tab at the top that basically has the repositories. Click on that tab, and then you go to that repository tab. And then once you're on the repository, the tab for activity for your repository, if you look over on the left-hand side of that screen, there'll be a thing that says your Subversion URL. And that URL is the one that you're going to connect to kind of the Windows client software that you set up. And so if you basically just click that, it'll highlight it. You can do a Control-C to copy the Subversion URL. That's what you're going to put into kind of the Windows version. Let me see if I can actually pull up the Windows client and show you how that would work. Let me see if I can get OBS to switch over to that. All right, hold on one second. Okay, so that seems to have worked. So here I am in Windows. So what I'm going to, in kind of a Windows File Explorer thing, what I'm going to do is I'm going to create a file. So new folder. I'll call it my game. And now if I right click on that, after I've installed Tortoise SVN, all right, that's not showing. Let me see if I can get an actual window to come up. All right, well, apparently the display is not showing. I'll have to figure out how to get this to work. But the idea is, here, let me go back to the window and explain what I'm doing here. So on this file folder that I made, that I set up, if I right click on that, it brings up a menu. One of the menus is SBN checkout. And it has like what looks like a little database cylinder with an arrow coming out of it. If you click on that, then that will bring up a thing that basically says repository, and it'll say URL of repository. So you're going to copy and paste the thing from the SVN repository for your game, and you're going to paste that into that URL of repository, and then it'll have the checkout directory below that will be the directory you just right-clicked on. And then if you just say OK on that, It's going to ask for the password for your repository, and that's going to be a password that you selected for it. You're going to put that in there, or the username and password. So your username will be whatever you pick for your username, password will be whatever you set for your password for you, SVN. And then when you click OK, it's going to fill in download all the things from the repository into this folder. And since I didn't actually set that up here, I don't remember my username and password, but the idea is that will fill this. So after you do that checkout, when you double click and go into this My Game, you're going to see any files that you put in there. Once you do put them in there, when you right click, you're going to go down to Tortoise SVN, and then under there, after you're connected to a repository, you're going to get a thing to be able to commit those changes. And so you can right click and commit those to upload any changes you made. So if you put new files in there, if you right click and say add to repository on a new file that you've added, then you can right click and then update that or commit that, and it will update that and any changes to make the source code. So try playing around with that with your team if you can. And then I'm going to try to figure out by next class how to do screen sharing properly, because for some reason my video device, I've done this on a desktop and it's worked. On my laptop it's not working for some reason, but I'll definitely try to figure that out by next time, because next time we're going to have to start doing some coding, and I really need you to be able to see the source code when I make those edits for that. So let me kind of finish up here. All right, so to finish up with where we are right now, going back here, set up your own repo on Ryu SVN, connect to it. You can set up multiple users on there as well, so you can don't have to share the same username and password. And I would suggest doing that for your project for a couple of reasons. One of them being that's important is that way when changes are made, you can see who made them and when, rather than just having changes be made. So you'll set up multiple users, connect them to your project, and then everybody can share the same SVN but log in separately to commit changes and download the thing. And then once you've done that, then you can actually all work remotely on the same project. Just one of the things about using SVN is you have to be a little bit disciplined with how to use it. So in other words, a lot of places what you'll do is you'll check out the SVN, you'll write your code changes, and then at the end of the day or the end of some development cycle where you finish something you're working on, commit those changes. In other words, don't wait too long before you do your commit. So when you get something that works and you're pretty happy with and it's stable, commit that at that point. Add change notes or commit notes with it to say what you changed and why. And then update so you get the changes that everybody else has made as well. And so that way, if you follow that process of checking out the repo, making changes to what you want to make changes to, committing the changes, and then updating, and then make more changes, commit, update, make more changes, commit, update, then you'll wind up with this kind of very good experience with sharing that, along with the history of who did what and when and where. Because every time you make a commit, it'll have your username associated with it and your notes that you added with it for why you made those changes. Again, set this up, try using it. If you have any problems, let me know. Send me email. But what we're going to look at next class, next week, is hopefully everybody will be able to get started on your project. One thing about those projects, go ahead and submit. I know we can't have in-person demonstrations or presentations of your project idea. Go ahead and submit the slides for your presentation along with the documents that answer the questions that were asked. Go ahead and just submit those on Blackboard, or if you can't submit them on Blackboard, then you can email me a link to it or email me the documents. But go ahead and submit those. And then next week what we're going to do is we're going to start into our kind of special topics part of the things that we're going to cover. And if I can't figure out how to get OBS to work right with my laptop device, and I'll do this from a desktop instead. But next class, what we're going to do is we're going to start digging into some of these special topics features that I think will help your game. So we're going to do a little bit with physics simulation with applying gravitational forces. We're also going to do a little bit with some other ways of representing large world spaces, kind of like we did with the tile-based side-scrolling. We're going to do some more with that, but in a slightly different way that can have some advantages. And then we're also going to do some other physics simulation, storing complicated information in files, and we're going to do some error handling and exception handling code as well. And if anybody's project is going to be network-based, or you want to do something that's kind of remote, multi-user simultaneously over the network, then I might briefly cover a little bit of network programming as well. So essentially, that's it for today. Everybody stay safe. Send me questions, put questions in the comments, or if you want, text me, email me, and we'll keep things going. Other than that, we'll keep working on your projects. If I were you, I'd start making some simple design documents and start building it. And I would put the design documentation inside of the SVN repo as well, or Git if you decide to use Git. But one thing about Git, remember, is I provided some resources there if you want to use Git. That shows how to use Git and GitHub. There's some tutorials there. And then GitHub.com is a lot like Ryu SVN, except it's much more widely used. I think that SVN is a little bit easier to get started with, especially with the integration with Tortoise SVN on the PC side. But whichever way you want to go with that, set up your project, start using it, start sharing that with the other members of your team, and work on your projects, and I will see you soon. Send me your questions.